All right. Hello, everyone. Welcome to Math 154, Week 8, Lecture 2. Per usual, going through some due dates first of all. My Math Lab 3.3 and 3.4 have already been finished. So those due dates you should have seen previously, and you can check my Math Lab for them if you cannot remember. 4.1 we will be covering today, so you'll get that due date as well. Your next Excel file on the docket is going to be 4.1 budget, as we discussed last time, I believe. And remember that, yes, we did. We did talk about that last time. Just making sure, I had to think about it for a second. Remember that you might see a 4.2 there, like it'll be like 4.1 and then a 4-2. That's just because it's talking about the assignment number versus the section number. Don't worry about that stuff. It's the one from chapter 4 that says budget with the due date that has been previously discussed. You will be assigned a quiz today. You will see the question during class, but the question is also inside of the quiz in Canvas, so it's a Canvas quiz. It's going to be kind of like the pay attention quiz and the syllabus quiz where you're typing your answers and then it should auto grade as long as you don't do things I tell you not to do, like don't type a sentence, don't type a paragraph, then you should get the correct grade. For little mistakes like an extra word or an extra period or comma or something like that, I will eventually review them all and give credit where credit is due. But remember that if I say to answer something as a quantitative reasoning student, and all you put is something that doesn't quite make you that quantitative reasoning student, that's not going to get you a lot of, if any, credit. Remember, numbers are not the only important thing in here. All right, so that quiz should be due in about a week. And then the discussion board is going to be from page 156. So this will also be discussed in great detail during the lecture. And what it's going to look like is it's going to be a table with some rows and columns. And there's 3 columns of numbers that you can fill out. And then it'll go based on year. So there'll be a row for, I think it starts with 2013. And then it has a row for 2014, then a row for 2015, and then a row for 2016, and it probably stops after about 5. Now, at first glance, you'd think that's only 5 opportunities, but because we can just automatically go to 2020, 2021, 2022, 2023, and just keep doing the process of what you'll see later, we can make it so that every single one of you has to participate. So please understand that you must participate in this discussion board. This is not one where, oh, well, everybody answered it. No, I could have 10 billion students and 10 billion students can answer this one. So there's 3 values in that table that you'll be answering. It's like a starting value, an interest value, and an ending value. I will actually complete the first 2 rows during the class, as you can see here. So whoever comes in first, don't you dare do 2013 or 2014 or whatever those first 2 rows are. I believe that's correct. Because I will have already completed them, that will not earn you points. So the first student that comes in does 2015. Then the second student comes in and they see 2015 done, so they do 2016. Then another student comes in and sees 2016 done, so they do 2017, and you just keep going up to the next year. You will have to use the last student's last answer because the ending value from the previous student will be the starting value for the next student, just like most finance problems work when we go from one year to the next. We've discussed that a few times, and we will continue to discuss that in this course. Please make sure that everything is rounded to the nearest cent, to the nearest penny. So don't say something is like $5 and then 0.239. That would be 24 cents, 0.24. So make sure you're rounding appropriately. If someone's off by a penny, again, that's not the point of the discussion boards. The point is to learn how to do the math to get these answers and to continue on. And I would highly suggest that all of you try and do maybe the first 3 or 4 on your own. That way you'll have good amount of practice. That way when you go into the discussion board and you see the one that you have to do, then you can fire it off in about 30 seconds because it really is just 2 processes. It's a multiplication and it's an addition, and that's the entire thing. All right, so without further ado, let's go ahead and get into chapter 4, 4.1. We're going to start talking about percents even more, and we've talked about them lightly before, but we're going to have even more in-depth, what's the word I'm looking for? discussion works. I wanted another word though, but we will learn deeper and more interesting issues with these percents. So let's go ahead and do that.
Head first into chapter 4, 4.1, percentages, something that we should all have a basic grasp of already because this is a prerequisite topic. But even with that in mind, I still want to make sure that we all remember how to convert between our percents and our decimals and our fractions, although admittedly, the last one is seen less often. So a percent is just another way of representing a decimal value number. Now, you might say, well, what about wholes? Well, a whole is a decimal value number. It's just you don't see the decimal. It's at the end of the number. So 4 is still a decimal. It's just 4 point. 4.0, 4.00, 4.000. Those would all be the same thing. Percent, the word percent, it starts with per, and we know what per means now. We've hammered that into our skulls by now, that per means the next thing goes in the bottom. And the word cent, think about in terms of money, 1 cent, it takes 100 of those things to make $1. So the word cent is, pun intended, centered around 100. So the word percent literally means per 100. So it's like you take something and you scale it to 100. It's scaling something to 100. That's the entire concept of percent. We like to think in terms of percents because it gives us a good breakdown of numbers. It makes it tangible quite often. And if you disagree, that means you just need to deal with them more and more and more, hundreds or thousands of times, because like with anything, it just takes practice and use to get used to something. All right, so that was weird. Converting between a decimal and a percent, it's all about moving a decimal place twice. It's always twice when you're going between decimals and percents. It's just a matter of whether you move it left or right. So some people go with the classic, all right, when you go from a decimal to a percent, you're going to memorize to move the decimal twice to the right. And then some people will say, all right, go with the classic when you go from percent to decimal. That means move the decimal twice to the left. And they'll just memorize these two little facts. And that's good. But if I just gave you a giant percent test and I gave you 10 problems in a row that were decimals to percents, then 1 problem that was percent to decimal, and then 2 more that were decimal to percent, and then 5 more that were percent to decimal, and then I just start blending them all willy-nilly, I bet you've got a more, let me say this differently. I bet you've got a more increased chance of getting one of those wrong because of all the back and forth. If I just give you 100 decimal percents in a row, you're going to get it down. If I give you 100 percents to decimals, you're going to get it down. But it's the fact that you need to be able to do this on the fly without knowing which one's coming at you. So when you're in that situation, you're a little more likely to make careless errors and just, oh, I'm going to go twice to the right when you were really supposed to go left. So that's why I give you this awesome trick right here, that a percent value should always look bigger than the decimal equivalent. So in other words, when you're just looking at the number without the percent symbol, that should look bigger, and specifically it should look bigger by a factor of 100. So what I'm saying is, let's say you had an example and you were supposed to convert 0.117 to a percent. If you were supposed to convert 0.17 to a percent, let's say you did this. Let's say you did this. You took its decimal and you said, I'm going to move it twice to the left. And then you got 0.0017, and then you tossed your percent symbol in there. So I had 0.17 and I moved the decimal twice. I know it's always twice. It's never 3 or 4 or 5 times when you're doing this type of conversion. And I chose to move it left, and I'm rushing, so I think I got that right. I go to the next one, and I keep going. Well, hold on. What's this little memo say that we were just talking about? A percent should always look bigger than the decimal. Again, so if you're just looking at the number that was with the percent symbol, 0.0017 absolutely does not look bigger than 0.17. This looks smaller, which says we did the whole thing wrong, but that little highlighted self-check is there to save yourself so many times. I can't tell you how many times it saved me, because I'm doing these things. Sometimes I'm going decimals percent, sometimes I'm going percents to decimals, and I'm thinking and I'm writing and I'm talking, and it's just so easy to go in the wrong order, and without asking, does it make sense, and without paying attention, that's where mistakes are made. So, okay, I know I was supposed to move it twice, but moving it left made it look smaller. So let's make it move right so that it looks bigger. Now we don't need to write this decimal because it's a whole, so I'm not going to write it. And then there's our percent. And 17 looks bigger than 0.17. That highlighted memo, oops, too far, has saved me countless times, and believe me, it will do the same for you. And the same idea, let's say you started with the 17%, and you said, I'm going to convert this to a decimal, so I moved the decimal twice to the left or right, and I'm panicking. Oh no, what do I do? I'm just going to go right. Okay, so that's 2 filler zeros, so then I get 1700. But what did Mr. Beckner say? He said the percent number should always look bigger, and that's because you're scaling it to 100. You scale it to a bigger number, the number should look bigger. We went through a guided activity where we kind of emphasized that. Excuse me. 17 does not look bigger as a number with the percent versus 1700, so that says I went the wrong way. Put it in blue. So when I had that 17 for the percent, I was really supposed to go twice to the left, which gives me 0.17. Literally the same thing as before. The decimal looks smaller than the percent, or the percent looks bigger than the decimal. Whichever way you want to say it, whichever way you like. So those are the two most common types of conversions you'll be seeing in this class. Admittedly, you'll be converting percents to decimals most, but we will still see some decimal to percent conversions as well. This converting a fraction to a percent, all you got to do is divide the fraction out. You got calculators, so you don't even have to worry about long division. Just type A divided by B, and then move the decimal twice to the right. Well, why do you do this last part? Well, because after you divide the fraction, you'll have a decimal, and then you're just converting a decimal to a percent. So it's kind of a two-parter. There is an alternative method to doing that in one step. I am not going to teach it. It's not that intuitive to most people. It's something we teach in our, or taught in our developmental maths before. I don't know if we're still teaching it because I haven't taught that course yet. It just started this semester. Anyways, there are other methods per usual. There's always other methods. I teach things to the point where, well, we've learned enough, we got to move on, or, you know, it's just a little bit too much all at once. Okay. So converting a decimal to a fraction, this is really not going to happen in here. This one is really rare. But you would say the number of decimal places is how many zeros you need in the denominator. So in other words, if I had something like 0.015, there are 3 decimal places, which means in my denominator, I need 3 zeros with my 1. And then all you do is just write that number in the top. So 0015 just becomes 15. And then of course you would reduce. I'm not even going to finish that problem because it's not the point. But 5 would go into both of those. I'll say it. It would then become 3 over 200. I'm just not going to write it. So this is not new material. If this is new material, you need to go out on your own and do hundreds, 200, 300, 400 of these, however many you have to until it's stuck in your head. If you're rusty with this, same thing. This is not what I'm here to teach you. I just spent 5-10 minutes working on it because I feel like it's a good reiteration. What we're here to teach you is how to use percents in word problems and concepts like finance, like gaining interest on an account or paying extra interest on an account, depending on whether you're borrowing or saving. Yeah, so that'll be what we're working on. So this is going to be one of our favorite setups for these percent style problems at first. Not talking about something called percent change, that's a whole different beast. Percent change and just regular percent problems, those are two different beasts that we will study extensively. So right here what I'm talking about is if I say, all right, 15% of 1,000 is what? Or 22 is what percent of 85? Something like that. Or a more contextual problem like Bob gets 1% APR on his savings account that accrues simple interest. How much interest will he gain after 1 year? Now, without actually saying it, I asked, what is 1% of however much he invested? I don't think I said that amount, but again, I'd give you the amount in the problem, as we will see. Okay, so this equation right here is how we are going to be working with our percent problems. We're going to have a part, a whole, and a percent value. And this is another case of we will get 2 out of 3 in the problem. In a problem, in order to solve this, you'll have to be given 2 out of 3. You'll have to be given the part and the percent, or you'll have to be given the part and the whole, or you'll have to be given the whole and the percent. You'll have to be given 2 of those 3 things to find the fourth. Do you know why that is? Because this is a fraction equal to a fraction. This is a proportion. This is a proportion that we have actually done before. We have had a part to whole relationship before, and we have scaled it to 100. This is not actually anything new. We're just laying it out in a more formulaic manner. This is just comparing apples to oranges, aka a part to a whole, and then scaling it to 100. This is just scaling to 100. That's what makes something turn into a percent when you scale it to 100. We had talked about that many times over. What are we scaling to 100? We are scaling the whole to 100. So we're saying, all right, if you have 55 M&Ms, but you want to think of this thing as a percentage, if Bob comes in and eats 2 of them, what percent did he eat? Well, okay, you have 55 M&Ms, but to think about it as a percentage, you got to pretend like you had 100 M&Ms. So we got to turn the 55 into a 100 by scaling it proportionally. Now the part would be the 2, the amount of M&Ms, excuse me, that Bob ate. Now, when we're actually doing these problems contextually, some people have a difficult time figuring out which is the part and which is the whole. Usually the part is the smaller value, but it doesn't have to be. It doesn't actually have to be for every single problem in the world, especially when we start talking about percent increase and decrease, which is a little different. But if you think about the problem contextually, you should be able to figure out which one is the part and which one is the whole. You just got to say what makes up the entire thing and what would be part of the thing. But another clue that you can usually find in the phrasing is you'll see the word of somewhere. And anytime you see the word of, the thing that comes after it is the whole. So this is just something that I suggest you memorize, because if you have a hard time, really cluing out that context, then that would help you. So I would say 90% of problems, notice what I just did there, that means 9 out of 10, 90 out of 100. 90% of problems usually have the word of in there somewhere. It doesn't have to be in there, but you usually see it. So if you see the word of, you know the next thing is the whole, which is what the bottom should be. The percent always goes with the 100, the part always goes with the whole. We've talked about part to whole ratios before. Again, lots of taking several topics and just squishing them together into one big, kind of circle. Everything is related to each other. Now, if you had a developmental math class or an algebra 1 class or whatever, where they say, okay, the of means times, is means equals, what number means x, what percent means p, if you were taught that and you know how to apply it 100% of the time, see what I did there again, then I am absolutely okay with you handling your problems that way. Per usual, as long as you have a method that will get you a correct answer, and that method isn't pulling the answers off the internet. As long as you have a method that will always make it work, I don't care how you get it done. I'm just teaching you a method that relates to what we've been studying for all of Chapter 2, all of Chapter 3, and what we'll continue to study in Chapter 4, proportions. So we're setting this up as a proportion. All right, so we're going to do several examples that I've just kind of made up. I mentioned that there's a quiz question in Canvas. I'm actually going to show you what the quiz question is for about 5 seconds. It's at the end of these examples. Then we're going to pull up our worksheets, And I'm going to show you page 156, which will be your guided activity to have done over the weekend, but I'm going to expand on it. So the guided activity only has 1, 2, 3, 4, 5, 6 answers, but I'm going to make it so that every single one of you can and will have to come in there and answer it. So every single one of you will have to answer this discussion board. So I will explain that in a few though. All right, so Bob, like every American earning money, oh, I want to make a joke. It's not even a rating thing. It's just a political thing, so I'm not going to say it. I bet you can think about what that joke is, though, but I'm not going to say it. Something about people paying taxes or not paying taxes. All right. Bob, like every American, most Americans, has to pay taxes, Social Security, etc. If Bob has 28% of his income withheld amongst those groupings, so when I say withheld, I'm talking about taxes, Social Security, your FICA, Medicare, all that stuff, whatever. Like, not FICA, that's credit score. What am I saying there? And he had $19,880, so about 20 grand withheld last year. So Uncle Sam took 20 grand from Bob. You know, Bob's probably not happy about that, but you know, there's some other things going on here, so let's not panic yet. What was his annual income? So first thing I want to say is the way your money is taxed is bracketed. So if you make up to a certain amount, then you pay 12% taxes. After that amount, you'll pay 22% taxes, but only on the money above what you've already been taxed on. I don't have those numbers off the top of my head, but let's say it was $10,000. So you pay 12% up to $10,000. But then every dollar you earn over $10,000 up till say maybe 50, you pay 22%. And then after that, you pay 24%, then it's like 30%. But it's not like the first $10,000 you pay 12%, all of a sudden now gets taxed at 22%. It's just the extra income you make that gets taxed at 22%. I've heard many, many people go, I don't want this pay raise or I don't want this bonus because it's going to bump me into the next tax bracket and it will actually make me earn less money. That is completely wrong. It is completely false. And the misconception there is that they believe from going from, say, a 12% to a 22% bracket, now they're paying 22% taxes on every dollar they've earned, which is wrong. They're paying 12% on the first 10 grand, and then they'll be paying 22% on any dollar from 10 grand up to 50 grand. And again, all of these are rounded, estimated numbers off the top of my head, so I don't have to look it up and waste time. If I had thought about it before class, I would have pulled those numbers up, but I just went on a little tangent, and my tangents can be random. All right, so take that bonus. Don't worry about making more money. You're still going to make more money. Now, if all of a sudden your medical insurance goes up $200 a month, that's another story. All right, so Bob has to pay taxes, and he had 28% of his income withheld. So some of his money was taxed at 12%, some was taxed at 22%, some was taxed at 24%. He also had to pay his Social Security and stuff, which is extra money besides that. You also have state taxes, which in Virginia, it's like 5.5 roughly. California, it's like 13. I think that's the highest. And that's if you make like $1 million, to be fair. It's bracketed, just like our federal taxes. So when all that is said and done, Bob had 28% of his money taken from him. And it turns out he had about 20 grand taken from him. And what we want to figure out is what is his annual income? So let's go ahead and try and make a prediction about his answer. What should the answer be in size? Should it be bigger than this 20,000 or should it be smaller than this 20,000? Well, if he has 20 grand, again, rounding, if he has 20 grand taken from him, I certainly hope that he made more money than 20 grand. Otherwise, Uncle Sam is leaving him in the red. If he only earns, say, $5,000, how would he have 20 grand taken from him? Because there isn't even 20 grand to take. So he's going to at least have to earn $30 or $40 or $50,000 for Uncle Sam to take 20 grand. If he earned $40,000, this 20 grand would be half of that. So that would be 50% singular, but this is 28%, so obviously he's got to make more than 40 grand. If he made $200,000, this 20 grand would be 10%, 20 out of 200, which that means he definitely didn't make 200 grand because he's being taxed at 28%, not 10%. So his actual income is somewhere between $40,000 and $200,000. Now that's just a small margin, but at least we have a good idea in case we did this wrong, for instance. So what are we doing? We're doing this part to whole proportion, where one side is going to deal with the numbers of his income and the other side will be a percent and a 100. This is automatic. When you're dealing with a problem like this, some percentage of some value, what was the whole, or you have the percentage and the whole, what was the part, anything like that, this is the first thing you should do if you're going to go with my method. So the right side is the percent, so that's where the percent number should go, which is the 28%. Now, some people will go, oh, okay, well, 28%, this is 0.28, so then they'll do this, they'll put 0.28 over 100, which is wrong. Because 28% as a fraction is 28 over 100. If you don't trust me, just put that in a calculator, and 28 over 100 is going to be 0.28. Remember, you've got calculators in real life, and this class is for real life. So be careful with that. That's one tiny thing to be careful with, that some people will convert this percentage to a decimal and then put the decimal here. But no, because this is a fraction representation of a percentage, the 28% literally means 28 over 100. So then the only thing is, where does this 19,880 go? Does it go here or does it go here? Which spot does it go? So what you have to ask is it the part or is it the whole? Is it the part or is it the whole? So is this roughly $20,000 part of his income, or is it all of his income? Well, we hope that his income is more than this, so it would definitely have to be the part. So we can logic our way through it that way. The part always goes in the top, so thumbs up. We don't know the whole, that's the question in any type of proportion. We always have a variable somewhere, so you can use any letter you want here. X is my favorite traditionally, so that's what I'm going to go with. Now, if you can't conceptualize why that's the part and not the whole, here's our word of, and we said that the something after the word of is the whole. What's the something that comes after that word of? His income, not what the government took, his income. So this should be the whole, his income should be the bottom. So that's just an alternate way to have figured out which goes top and bottom. I'm giving you multiple methods. I'm giving you logic and I'm giving you word associations, because I know some of us like logic and some of us like word associations. How do we solve this? Well, you know how to solve this. You better know how to solve this. You cross multiply, so you get, when I multiply the 19,880 by 100, it's just going to put 2 more zeros up there. So here's the times 100 part, which now makes that 1.988 million. And then that will be equal to 28x. To finish it, we divide both sides by 28, which will tell us that our answer is, drum roll, 1988000. That looks right, divided by 28, and we get 71,000. So 71,000 is equal to our x. Now remember, whenever you get an answer, that doesn't mean it's the answer. What is its income? If you say 71,000 this way, nope, that is wrong. Technically speaking, we're QR students. We know units are critical. Is it 71,000 apples? Is it 71,000 yen? Is it 71,000 bobs? No, it's $71,000. That was his income. I don't want to write X there. I want to say income. And it makes sense because he paid less taxes than his income, and this income isn't some exuberant amount. Like I said, $200,000. If you're taxed 20 grand, that's 10%, because 20 grand out of 200, if you did that division, you'd get 0.10, or 1/10, or 10 over 100, however you want to represent the number. So if I'd done this wrong, if I had said the 19,880 was the whole for some reason, I'm just not thinking, I'm not paying attention, I'm doing things quick, I'm talking to other people at the same time, whatever, and I got everything else right, and you put your x there. When you cross multiply, you're going to get 100x is equal to the 28 times the 19,880. I'm going to go ahead and just write that. 28 times 19880, 556640, 556640. Then we'll divide both sides by 100. Again, this is wrong. Divide by 100. And we get 556640. 5566.40, since that's our money income. Question mark? We made $5,000, we made $5,500, and Uncle Sam took 20 grand? That makes no sense. How are we making $5,000 but Uncle Sam takes 20 grand? Now you might say, well, he's garnishing our wages. Even still, they can only garnish exactly what you make. And I hope you don't end up in a situation where your wages are garnished. Pay your taxes, be a law-abiding citizen, all that good stuff. I have another, just silly teacher / I guess dad joke, but I'm not going to say it for a recorded video. Y'all got to meet me in person if you want the dad jokes. What is 40% of 230? Oh man, this is just a boring math problem, isn't it? But I mean, maybe there's a reason you're doing this on your own terms. Maybe maybe you borrow $230 from somebody and they tell you that they want a 40% VIG, which means you've got to pay 40% extra a week later or a month later, depending on whatever their frequency is, or a year later, which is a significant chunk of money. But okay, if I want to borrow $230 and this guy wants another 40% on top of that, how much money am I going to have to pay him just for this loan? Well, you do 40% of 230. So you're asking yourself, what is 40% of 230? So again, this could have been paired with an actual problem, or it could just be a really boring math teacher coming in and saying, what is 40% of 230? All right, well, context or no context aside, we definitely cannot figure out which one is the whole or the part just based on logic and reasoning here. So that's why you have to know that the thing that comes after of has to be the whole. So that of memorization would be critical there. So we're going to go, oops, wrong color. It doesn't matter. 230 in the bottom. That'll be equal to something over 100. The 40% is the percentage, so 40 goes in the top, not 0.4, not 4,000, it's just 40. And then the part is the unknown. We cross multiply, and we'll get 100x is equal to 40 times 230, will be 9,200, 230 times 40, 9,200, just showing you that in case you didn't trust me. Divide both sides by 100, which we can just cancel two pairs of zeros. You don't even need a calculator for that. And that says that x is equal to 92. What is x? What units does it have? I have no idea. This problem doesn't give you any clues to that, so it's just x equals 92. Again, there's no context to this problem, so we can't necessarily make sense of it unless we're just really good with our numbers. We're numerate. And we know that this is exactly how the problem should have flowed. But again, in the real world, it's pretty rare that you're doing a problem on your own for no reason with no context. You're going to have context for doing this problem. The point is being able to set it up in the math terms and solve it, and making sure the answer makes sense. All right. Next up. 95% of students did not like today's quiz. So this is a very, very strong dislike. What quiz? It's not actually the quiz that you're doing today. Trust me, it was just a made-up statistic. So 95% of students did not like today's quiz. If there are 15 students, how many students didn't like the quiz? Now, we're going to get an answer, and then I'm going to say, I'm not telling you anything about rounding, spoiler alerts, but there would be a reason to maybe say the answer is different than what we actually get. And let's get to that point when we get to it. For now, let's set up a proportion. So fraction equal fraction. because we're talking about a percentage of something and some part or whole. So that's it. We're not talking about change, which leads us to things later in this section. We're not talking about years later, which leads us to things in another chapter. It's just fraction equal fraction still. Where one of the bottoms is 100, you can make the left bottom 100 if you want, as long as the 95 goes with it. The 95 goes with the 100 because that's the percentage. 95 out of 100, that's what that means. 95 out of 100, or 95 per 100. That's what 95% means. There are 15 students. How many didn't like the quiz? So what we got to figure out now, is this the P or the whole? Is it the part or the whole? The P or the W, the part or the whole? So we have 15 students and we're saying how many didn't like the quiz? So we're saying there's 15 students. Could 16 or 17 or 20 students not like the quiz? Well, no, that's not possible because I'm telling you there's 15 students. It's possible 15 students don't like the quiz, but it couldn't be 16 because there's only 15 total, so it has to be the whole. So the 15 has to go in the bottom. Now, another way you could have figured this out is the word of says the next thing goes in the bottom. So of students, that says the number of students goes in the bottom. Here's your number of students, so the 15 goes in the bottom. That's two different ways to set that up. Well, that makes this the x. We're going to cross multiply, so we get 100x is equal to 15 times 95. I'm not doing that in my head. I could if I had another 10 seconds. That's 1425. Finish this up. We divide both sides by 100. Told you don't get to forget how to solve those. And then 1425 divided by 100 is just going to make a decimal here, move left twice. You can show the division if you absolutely have to, but you will end up with 14.25. And for this type of problem, I'm going to say that this is not a great answer for two reasons. First of all, there's no units, so it's a horrible answer. So that says it's 14.25. What's the units? We're talking about students. 14.25 students, question mark. So we're talking about a very small population, 15, 16, 20, 30, even 100 or 200 students. And we're saying that 14.25 students don't like the quiz. You can't have 0.25 of a student. You can't have 0.25 of a student. So I would say this would be a problem where you should expect to just know, you should round this to 14 students. So it's not like one of these students, 25% of a student didn't like it, and then the other 75% of that student did like it. That's multiple personalities, and I'm not going to insult that or talk about that at all. I'm just saying that that would be like a comparison thing there. But yeah, and that's because we're talking about a small size. We're talking about a small population. This is where we usually round to whole numbers. Now, if I gave you a problem where I said, like, out of a population of 251,000, so 330,251,917, and then you had some percent, blah, 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 and then your answer was x is equal to 14.25. This is okay in this sense because we're talking about a very big population size. If you look at census statistics, they'll say something like the average household is 5.3 people or 4.7 people, something like that. It's a ballpark value. I'm not using an actual statistic here. As you know, 75% of statistics are made up on the spot. Ha ha ha. That was a joke. A bad joke, but a joke. So I know you're like, why can I call it 14 here, but 14.25 here? Again, it's about the context and size of the problem. If we're talking about a small population, we generally round people to whole numbers. If we're talking about a massive population, we generally are okay with people having one or two decimal places. And I know that still you're probably inclined to say, well, 14 students here, but again, it's just a normalized standard that 14.25 would be okay for large population sizes. All right. There's that quiz peeking at you. 71% of the Earth is covered in water. This is not the quiz. If 140 million square miles are water, what is the total surface area of Earth? Oh, we're talking about percentages. We have one of the values, either part or whole, and we're looking for the other. We're going to set up a proportion, fraction equal fraction. All right, well, I know one of these fractions because we're talking about percentages. The bottom has to be 100. Also, if you like setting up proportion tables, you can do it that way. You can set up a proportion table with this. We are literally doing the same thing over and over and over. You can do a y equals kx with this, believe it or not, but I'm not going to teach it that way. If you figure it out on your own and you can always get it right, then do it that way. I just want to focus on the method that most people are more consistent with. So 71% of Earth, that has to go with 100. That's automatic. Don't overthink that. The percentage goes with 100. 140 million square miles are water. So we're just trying to figure out, is this the part or the whole? So 140 million square miles are water. What is the total surface area of Earth? So we've got to ask, is 140 million square miles of water part of the surface area of Earth or all of the surface area of Earth? Well, think about this. What are you sitting or standing on right now? Are you in the middle of an ocean or a lake? And if you are, that might be pretty cool. But most of us, if not all of us, are on dry land right now. So no, water is not all of Earth. It's just part of the Earth. The total surface area of Earth is the whole. So the 140 million, just contextually using logic, has to be the part. Now you can write the 1,4 and then all those zeros if you'd like, but why not just say that this bottom is in millions of square miles and then the top would have to be in the same type of unit. So these are not rates of two different things. This is a ratio of the same type of thing, square miles to square miles, people to people, oranges to oranges. So here's our x, we cross multiply. Oh, and also the other way, 71% of the Earth is covered in water. 71% of, the next thing should be the bottom, the Earth. The covered in water part is not what's immediately there. That's another thing. It's saying 71% is covered in water. So of the Earth, that says the Earth is the whole, which makes the water the part. All right, so when we cross multiply, 100 times x is equal to 71 times 140. Definitely not going to do that one in my head. Where's my mouse? There it is. 71 times 140. And we get 9940. I don't know why. I just feel like that number isn't right. No, it is. I just thought I had a different number in my head. And then divide both sides by 100. Just making sure I didn't make a goofy mistake somewhere. And the same thing, dividing by 100 just essentially puts a decimal 2 places left. So that's 99.40. That is not the answer. If you just say that, that's wrong. At 99.40 what? It's 99.40 or just 0.4. You don't really need the zero since we're not talking about money. Millions of square miles. And that would be of water. Does that make sense? Well, if there's 100, now I knew I was doing something wrong. So this is perfect. We did it wrong, and this is perfect. Does it make sense? No, it doesn't make sense because the 100, and the funny thing is I was going to do this problem wrong after this anyway, so you're just going to see the same thing. The 140 million square miles are water, and we were asked for the total surface area, so of surface. That was the first thing I did wrong. So if there's 140 million square miles of water, how is it that the total surface area of Earth is 99.4 million? That includes the water and the land. So this has to be wrong. The total surface area of Earth should be more than the water, and that's because what I did wrong in this process, I talked out the parts and wholes correctly. I said that water is the part this 140 million was the water, and I put it in the bottom. That was my mistake. Again, I was going to make this mistake after doing it right, so we just got to do it first wrong anyways. So that was fun. Again, this is the beauty of teaching quantitative reasoning, because I talked this thing up correctly the whole way. I made a simple mistake because I'm talking and writing and reading at 3 different speeds. Multitasking is how we make mistakes. But in the process, I analyzed my answer and I said that makes no sense. So we say that's wrong, and now we're going to set it up based on what we actually said. The 140 goes in the top because it was the part, the x goes in the bottom. And that's why when I was right here, I was like, something doesn't look right. So now when we cross multiply, we get 71x equals 140 times 100 is just 2 more zeros tacked on the 140. We divide both sides by 71. And that tells us that x is equal to 14000 divided by 71. And there we go, 197.13, blah, 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 blah. Let's just round to 2 decimal places, 197.18. But that's not our answer. It's supposed to be 197.18 millions square miles, and that's of Earth, or of surface area, however you want to phrase that. That includes land and water. That makes sense because 140 million square miles is water, which means then that leaves about 60 million square miles of land. Also, if you know anything about Earth, Earth is 71% water, just like people are about 70% water. So this would make sense. 140 is about 70% of 197. But there's so many different ways you could have just gotten this answer wrong contextually. If you forget the million, if you just say there's 197.18 square miles of Earth, that's definitely not right. There's more than that many square miles just in Virginia alone. It's more than that many square miles in just Hampton Roads alone. All right, so that was fun. Not even going to apologize for making that silly mistake. Because like I said, I was going to show the work done that way anyways and why it made no sense. I just happened to do it unintentionally first. All right, so this is going to be the quiz question you will find in Canvas. Again, that should already be up there. Answer it as a quantitative reasoning student. Do not answer this as a sentence. Do not, in your Canvas, don't show all your work and give me the explanation and a sentence answer. Just give me the number and whatever else might go with the number, okay? So you already know if you don't give me enough information, you're going to be penalized pretty harshly with this, even if the number is correct. Answer it as a quantitative reasoning student. If you do want to answer it as a sentence, just know that it's going to say it's wrong at first, and I'm going to have to go back and overwrite the grade, and I will still go check everybody's grades, because if you have a misspelling somewhere or something, then it could be wrong. So just note that you might have an answer right, and I got to go back and fix it just like a previous quiz. That's just the complication of doing these Canvas quizzes. I miss just doing the hand-graded ones, but the little printout sheets that I had you do for the video quiz, I don't like doing a lot of those because they take 5 times as long to go through. Okay. It was fine when they were printed. I could fly through those, but the digital stuff takes too long to pop up. So I have to think about time efficiency. All right, so that will be your quiz question. We are not getting to 4.2 yet. I've got to open up our guided activity. Not assignments, e-text, chapter 4, guided worksheets. So page 156. Here we go. So page 156 of your guided worksheets, guided activities, whatever you're calling them. This is going to be the problem for the discussion board to do between now and Tuesday. I'm going to do a write-up of what I say afterwards, But you can see how this has a row for March 31st, 2013. So basically this is just a row for every year. Then 1 year later, 2014, 1 year later, 2015, 1 year later, 2016. So I'm gonna do 2 rows of this. I will complete 2 rows of this, and then y'all will do 15 or 20 or however many students are currently participating in the course. And you'll go through and do, so student 1, so S1, stud 1, stud 2, stud 3, student. Then student 4 comes in and does this one. And you go, well how's student 5 do anything? Come on, think. What are you going to do? You're going to do 2019. So student 5 will come in and do the March 31st, 2019 value. The next student, number 6, comes in and does the 2020 current year's value. Then student 7 comes in and does 21. Then the next student does 2022, then 2023, until every single one of you has done this, or you just don't get credit. So you must participate. I say that some of them you may not get to participate, and that's okay. This one, every single student will have to participate in this one. And this discussion board is going to be due on, drum roll, not the 24th, the 26th. So this will be due Monday, 10/26 by
I said something silly here.
11:59
Don't worry,
p.m.
muting
per
is
usual.
intentional.
Remember, I like discussion boards every week going to be doing on Monday, because it's not like you're doing a ton of things. You just come in, see what year is left off. You're going to multiply something, you're going to add something, and that's it. Every student could do this in theory in about 15 seconds themselves for 1 row. Page 156. All right, so like I said, I'm going to do the first 2 to show you how this works, to give you a start, a push in the right direction, and then thumbs up. And then again, student 1 comes in and does 2015. Student 2 comes in and does 2016. If for some reason 2 of you are working on the same thing at the exact same time and both post 2015, that's not the end of the world. It would be cool if one of you noticed that and then comes in and does 2016, but most of us aren't going to be working at exactly the same time. And it's, again, it won't take you 2 hours to do this once you see where someone's left off. So someone shouldn't come in and steal your thunder. But again, if they do, you'll have already figured out what to do. So you just take their number and multiply, add. And that's all it really is. All right, so let me clear my screen because I need to pull this back so I can read everything. I have a menu in the way. Oops, not that. Clear. Take that off. Let's back up. So assume someone had $100,000 in their retirement account on March 31st, 2013. So there's a little typo there. That should say March 31st, 2013. I can't write in that space, unfortunately. That's where my menu is, the Zoom menu. The 5-year rate of 3.98% means that each year, the initial balance will grow by 3.98%. So this is a concept of our balance is going to grow. This is where we're making more money. So we'll have $100,000, and then we're going to have like $105,000 or $110,000, $103,000 more money. To find out how much money they will have in their account 5 years later, we can fill in the following table. This is going to use the idea of simple interest. We have talked about the idea of simple interest, where the amount of interest you earn is the principal times the rate times the amount of time, but we're going to only look at this over 1 year. So that makes t equal to 1 each time. So a better way of saying this is that the interest is just the principal, or the current balance, times the interest rate. So again, it's the current balance times the interest rate. Write out these formulas however you like, however it makes sense to you. This was one of the very first quote formulas we gave you back in chapter 1, those finance formulas. How do you find an interest? You take the balance times the effective rate. Now, when we get into chapters 6, 8, 9, and we start talking about compounding interest, this will work a little different because we're going to compound on months instead of years usually, but we'll get there when we get there. For now, we're keeping this simpler. So when I want to find the interest for year one, I just take the principal times its interest rate. Now this 3.98%, you've got to convert to a decimal. So its decimal goes left twice, which becomes 0.0398. You cannot use it as a percentage unless you're doing your work in Excel. Excel can handle percentages, but our traditional math can't. So this is our multiplier. This is our interest rate per year. So we just take the principal, or the current balance, excuse me, the $100,000 times the 0.0398 to find the interest. So for this block, where do I want to say, what I want to do, I want to clear my screen. This is why I don't like writing on this thing usually, but I tried and I failed. All right, so again, interest is the current balance times the interest rate. That's our formula. So for this spot, what I'm going to call A, for slot A, the initial principal was that $100,000. That's what we started with because we had $100,000 on March 31st, 2013. So that's 100 grand. No math to figure that out. But this spot B, what I'm going to call B, the amount of interest we earned for that whole year will be the $100,000 times the interest rate, which we said was 0.0398. So we take the $100,000 times the 0.0398. Annotate, get my calculator, there we go. So 100,000 times 0.0398, and we end up with 3980. Oops, back on annotate. Calculator up there though, for this part. There we go. 3980. So the amount of interest, and these are in dollars, so that would be 3980. That is the amount of money Bob just got for free by having $100,000 sitting in an account for a year. So again, this money was sitting in the account for a year. So on this date, they're going to compound their interest. They're going to gain their interest. So the SunTrust or BB&T or whoever, they take this $4,000, they deposit in their account. So how do we find the ending principal? Let's call that block C. C is going to be well, the previous balance plus the money you just got for free. It's your 100,000 plus your 3980, which is going to be 103980. $103,980. That's this entire concept. So now, from March 31st, 2013, or April 1st, whenever the money hits your account, until March 31st, 2014, this is how much money you have in your account. So the initial principal here is the same as the ending principal here. Again, going back to the beginning of the semester, this is something we talked about with Excel, where we can link a new balance to an old balance by just going equals and then whatever this cell reference was. But we're not using Excel here, so this is just the same thing of $103,980. So that would be block D. I'm not even going to write that down there. My block E here is our interest. Now, before I get the answer, let's ask ourselves, do you expect this number to be the same, less, or more? Well, if $100,000 got us $39.80, now we got $103,980. So I would expect that number to be more. So this number should be more than 3,980. Now, we don't have a lot more money in our account. It's not like we doubled or tripled our money all of a sudden. So I'm not expecting this to be like $10,000. I expect it to be close to 4,000, but at least a little more than 3,980. And as we progress through these, we're going to notice there's going to be decimal places. Let's just keep our money rounded to the nearest cent because that's how we round money, generally speaking, unless told otherwise. So for block what I called E, that we're going to take not $100,000, it's the current balance. We have $103,980 times our interest rate of 0.0398. So let me go off of annotate. 103,980 times 0.0398. And we get $4,138.40 rounded to the nearest penny. 4138, so this is dollars still. 4138.40. And then block F, we're just going to take block D and block E and add them. What we had in the account plus what the bank just gave us for free. So we're going to take the 103,980 and we're going to add the 4138.40 to give us 108,118. 108,118. Sorry, it's a little sloppy. I really dislike, you can see the answer in the calculator at least. This is what that should be. Is there anything crazy mathematically we're doing here? No. The first student to come in here, now remember, you are doing an entire row of these. Each student has 3 answers. You need to come in and say, my initial principal is this, which your initial principal will be the previous student's ending principal. Then you'll calculate the interest. I would appreciate it if you say that as a sentence. I'm going to take this number times that number and it gives me this, and say it as a dollar amount. And then you'll come in and say, okay, with that interest amount, I add that to what my previous balance was, my current balance was, and then that'll give me my ending balance of whatever this is. Again, there is nothing complicated here. If you think this is complicated, I would like you to do, maybe personally on your own, just do 3 or 4 or 5 of these on your own. But again, I'm not grading that. The discussion board is come in and do whichever one is next. So if the previous student did 2025, you're doing 2026. But my suggestion to practice and get the rest of these answers would help you. That way you'll have practiced, you'll be able to do it quicker, and it's not like it's going to take you 2 hours and then someone comes in and steals your thunder and you got to do the next one. I will say that if things are going smoothly by the time you get to the 2017 date, and make sure you're saying the dates, which specific row you're doing in your work. This is about 121,500 something. I'm not going to give the exact amount. So that's 121,000 and some pennies. But if the student coming in for 2017 says that this is 200,000, something's gone wrong. If a student comes in for 2017 and says this is 82,000, something's definitely gone wrong because you've lost money. So this is, again, one of my favorite types of introductory problems to the idea of gaining money, because we're actually introducing ourselves to the idea of compound interest. Because that simple interest formula, we would think, oh, well, I can just find the 2018 amount by multiplying by 5 years. It doesn't actually work that way in the real world. You're going to gain interest, your money, every month or every quarter or every 6 months or every year, every day, something like that. So again, this is introducing us to that concept that we will expand upon in a later chapter. And this discussion board will be available, I'm going to say by an hour after class, maybe an hour and 15 minutes after class, something like that, roughly, is when I'll have it available. Here's a good problem between converting percents, fractions, and decimals. If you feel like you need more practice with that, again, this is not what I'm here to teach, so we're not doing that, but you might feel the need to try those out. You can always ask me, for answers of other stuff that we don't do. That's fine. I don't mind giving out those answers if you email me. But I wanted to look at a couple of these. We typically encounter percentages less than 1 when dealing with what we call periodic rates. So the example we just spent a long time talking about was dealing with an annual percentage rate, an APR. And when you talk about things in the real world, you're generally given an APR. When you go get a credit card, they'll say, oh, this is 18.5% APR. And when you go get a savings account, they'll say this is 0.62% APR. Or if you go invest into some bond, they might say this is 4.1% APR. So that would be the rate you'd get over a year if your money was growing every year. But again, in the real world, your money usually grows quicker than that. Your money usually grows every month or every week or maybe even every day, depending on the type of account you have. So that's when we get to even smaller periodic rates where, okay, if you earn 12% every year, your monthly rate, if that's what your effective rate was based on, would be 1% per month. And then those would add up to 12%. But we know that when we compound monthly instead of yearly, we end up gaining a little bit of money, a little bit more money. We did that at the very beginning of the semester. So again, these periodic rates, this is something we're going to see over and over and over and over and over moving forward. And these are typically smaller numbers because our annual rates are usually like 4, 5, 10, 20. And when you divide those by 12 or 365 or whatever, they become significantly small. So for each of the following, compute the periodic interest rate and the periodic interest for the first period. Avoid round-off error by using the full decimal expansion. Excel is great for this. This is the thing I was mentioning earlier. When you're doing that discussion board by hand, you're going to have round-off error. Eventually, the answers are going to be off by a couple pennies. Again, not a big deal. But if we wanted exact answers, then in our calculators, we would have never rounded anything. But again, for the discussion board, you're always rounding to the nearest penny so we can be consistent. But for this problem, we're going to say avoid the round-off error by using the full decimal expansion. So I am getting sick of the annotate thing. So let's do this way. All right, so with an annual percent rate of 8%, but we're going to be paying or getting our money monthly. So this is compounding monthly. That word is going to be seen over and over and over soon. And we have a balance of $2,500. So they said this was a loan, so we borrowed $2,500, or this was just our balance. Currently, it's exactly $2,500, which is pretty rare. So maybe we borrowed $2,500, excuse me. And the people we borrowed it from want a monthly payment of their interest, and they're going to make 8% annually. Because they're getting their interest monthly, we have to convert the annual rate to a monthly rate. So the monthly rate would be the annual rate of 8% divided by, well, how many months are in a year? 12. Again, this was a formula that we gave you back in those chapter 1 notes, that a periodic rate is equal to the annual rate divided by the number of periods. Again, the periodic rate is the annual rate, APR, divided by the number of periods. So if we want a monthly rate, we divide by 12. If we want a daily rate, we divide by 365. If we want a quarterly rate, we divide by 4. If we want a semi-annually rate, we divide by 2. And you can even get weirder than that, but those are the typical ones. So 8% divided by 12, which is really 0.08 divided by 12. We're not Excel, so we do 0.08 divided by 12. And we get 0.006666666666. So when I write my answer here, I'm going to round it to 0.067. Now, that is an actual answer, but it's a decimal. We like to see our rates as percentages. The annual rate was written as a percentage, so let's convert this to a percentage. I'm missing a 0, aren't I? Yes, I am. That was 0.0067. So when you move the decimal right twice to convert it to a percent, you get 0.67%. So an annual rate of 8%, so paying down a loan 8% over a year is very similar to paying 0.67% every month. So there's our monthly rate. So that means that our interest amount will be the periodic rate times the balance. So our balance is $2,500, and we're going to multiply that by our periodic rate of 0.067%, which again is just the 0.0067. But I'm not going to write 0.0067. I'm going to, in this calculator, this has it stored as 0.00666666666666666666666666666666. It displayed the 7 as rounded, but it still got the 6s going forever and ever and ever. So here's what I can do. I can just hit times and the 2,500, and this is how we avoid round-off error. I didn't type 0.0067 or 0.006667. I didn't even type 0.0066666667. I had to count for a second. That is taking an infinite amount of those 6s and multiplying by 2,500. So when I hit enter, there is no round-off error there. There is no rounding until I actually say this is 67 cents. If you don't trust me, here's me taking the 2,500 times the rounded answer I had was 0.0067. Let's see what that gives us. 1675, a slightly different answer because we used a rounded value to calculate something. When you use rounded values, you create error propagation. Is it a big error? No. But this is how, maybe a bank steals money potentially. I don't know, or somebody, maybe not just a bank. Or maybe it's just you going, hey, the bank should have been, or I should have had to pay $16.75, but I only paid $16.67. Why didn't the bank charge me that extra 8 or 9 cents? Well, because you used a rounded number and the bank used the actual number. All right, so that is all the time we have, unfortunately. We're not going to be able to get this next one done in time. But I will say you're just going to take the 20%. I'm not going to have time to write it, but I can at least say it. Take the 20%, which is 0.2. It's another monthly, so you divide it by 12. So this would be the periodic rate as a decimal. If you move it right twice, you would get 1.67% monthly. And then you'd multiply the 0.01666666 times your balance of 2,500, and you get your interest of 41.67. What is this demonstrating? It's demonstrating the difference of just like an average loan, maybe even a little high right now with our current very low rates. 8% borrowing $2,500, you're paying $16.67 in interest that month. Versus if you have like a credit card, you'd be paying about $42 that month. So that really demonstrates how credit cards are bad, and those credit card interest rates are usually in the ballpark of 20%. All right, so we know what we have due.
Again, so you got your 3, 3, 3, 4, and 4, 1 homeworks on the horizon, your 4.1 Excel, you have that percent quiz that we covered and discussed, and then the discussion board that we also discussed very extensively. Remember, you're responsible for an entire row. Make sure you say which year you have done, and make sure that when you do your year that you look at the previous student's answer. In an instance where maybe the answer you think it is and their answer is off by like 5 cents, just go with theirs. Now, if they're off by thousands of dollars, that's another story. You should make a little memo and say, well, this was what I had for the previous year, and that's what I'm going to go off if you think that's right. And that can encourage even more discussion per usual. But besides that, have a good day, and we'll see you next time for week 9.